Well, welcome back. We've got a great topic on interpreting the graph of the velocity function. So we've had lots of practice with accumulation functions. We're really going to focus on position, velocity, and acceleration tonight. And I just want to remind you about the order. We start with x of t, which is position. Okay, if I derive that, I get velocity. And if I derive that, I get acceleration. And those are the three we use in AP Calculus this year. Now, if I want to go backwards, remember, we're going to integrate. So position, velocity, acceleration. All right, our first example. Brina rides her bicycle from her home to Sarah's home, starting at t equals 0 minutes, and arriving at Sarah's home at t equals 15. During the time interval 0 to 15, her velocity, v of t, in miles per minute is modeled by the piecewise linear function whose graph is shown below. All right, so it's very important that you read the situation and underline what you have. So the first thing I want to be clear about is let's highlight those. This is v of t, okay, which is in miles per minute. Okay, so we have a velocity, we have a rate. All right, the second thing it says is that Brina leaves her house at t equals 0, and she doesn't get to Sarah's house until t equals 15. Okay, now here's what's got to be going through your head. When you see velocity, we need to be thinking, and let's star that, this is all about direction. Okay, and we've talked a lot about position, velocity, acceleration. When you see velocity, you need to think direction. Are you moving to the right or to the left? All right. Now, let's kind of watch some other details here. Obviously, they counted from 1 to 15 here. Did you catch this bear trap here? This is not 1, 2, and 3. This is 0.1, 0.2, 0.3. Be very careful with that. All right, letter A. After leaving home, okay, Brina realizes she dropped her calculus homework, heaven forbid, and she returns to get it. At what time does she turn around to go get it and give a reason for your answer? All right, so here's what a calculus student needs to be doing in their head at this point. All right, they need to say, okay, velocity, direction. This section here represents Brina riding her bicycle to the right. Okay, right here when velocity equaled 0, her bicycle came to rest. She stopped riding, she's stationary. This section represents her riding her bike to the left, again, coming to rest, stationary, and then the whole rest of the time riding her bike to the right. Okay, so the question says, she drops her homework someplace. At what time do you think she went to go get it? Hopefully it's pretty obvious to you, and I would say at t equals 4. So let's talk about our justification. Well, we know we were riding to the right, we came to rest, and we're riding to the left. So I would say at t equals 4, v of t changed signs. Okay, so I know I went from riding to the right to riding to the left, so that's where I must have stopped to go turn around and go get my homework. All right, part B. Find the acceleration, if it exists, of Brina's bicycle at t equals 4, t equals 10, and t equals 12. If it does not exist, explain why and indicate the units of measure. All right, now I think this is fairly simple. Okay, keep in mind you have velocity. You gotta remember who this is a graph about. That's why it's important to label it. The question wants to know about acceleration. All right, so that's the first thing I'm highlighting. I need to know a of 4, I need to know a of 10, and a of 12. Okay, another way to say that, another way to say a of 4 is to say the what of velocity. V prime of 4, v prime of 10, or v prime of 12. Okay, those clearly mean the same thing. All right. So again, I'm saying I have velocity, I want acceleration, I'm going to look at the slope. Hopefully that's what's running through your head on this problem. So I'm going to go to 4 and I'm going to say, okay, I need to calculate the slope there. All right, now that 4 happens to fall on this line. So basically, if I figure out the slope on that line, I know anybody who's sitting on this line here. All right, so I'm going to do a quick slope formula. I'm going to say, okay, this is the point, let's see, 5, negative 0.2, and this is the point 3, comma, 0.2. And I'm going to do a quick slope formula. Okay, change in y over change in x. So I'm going to go negative 0.2 minus 0.2 all over 5 minus 3. Okay, so I get negative 0.4 over 2. All right, now, we don't have a calculator. Maybe that bothers you. All right, I think that's pretty simple. Negative 0.4 is really negative 4 tenths. 0.4 is red, 4 out of 10. Divided by 2. Dividing by 2 is the same as multiplying by 1/2. Okay, so I would say that's negative 4 over 20, negative 2 over 10, or negative 1/5. All right. Oops, it said indicate units of measure. All right, so keep in mind velocity. Oh, shucks. I believe it was measured in miles per minute. You'll have to correct me if I'm wrong later on. I believe it was miles per minute. Therefore, if velocity is miles per minute and I want acceleration, I should be getting miles per minute squared. Remember, we're adding on a per when we take a rate or a derivative. All right, v prime of 10 or a of 10. All right, so I want you to go to your graph. I want you to look at v of 10 and just say to yourself, I'm looking at the slope if I want acceleration. Now, we know the answer right away. We're all saying does not exist. Okay, but now what is the AP going to give you credit for? You cannot say because the graph comes to a corner. All right, that is not worth any credit. Let me say it again. You cannot say because the graph comes to a corner. All right, you have to use the definition of a limit. Okay, this is the only justification they're going to take. The limit as x approaches 10 from the left of v prime of t does not equal the limit as x approaches 10 from the right of v prime of t. Okay, I want to be very clear. That's the only definition we're going to take. All right, lastly, we need v prime of 12. Let's go back to that graph. One of my favorites, absolute favorites here. I'm looking at 12. What would you say the slope is right at 12? Hopefully you said right off the bat, a nice big fat 0. All right, suppose Elvin starts riding his skateboard from his home to Sarah's home at t equals 0 minutes, arriving at Sarah's home at t equals 16. During the time interval 0 to 16, the velocity in miles per minute is modeled by this function, v of t equals 1/20th radical t. Who traveled farther, Brina or Alvin? Show work that leads to your answer. Okay, now, here's a new topic that we need to cover tonight. All right, so I'm going to kind of take a pause here for a moment, and I want to talk about these words. If I want to know who traveled farther, I want to compare something called their total distance traveled. Okay, and this is a term we're going to see quite a bit this year. Total distance traveled. Okay, total distance traveled is the absolute value of velocity. All right, so let's get that in our notebook. Let's star that. Total distance traveled is the absolute value of velocity. So what I want to do is I first want to start with Brina. All right, so on your notebook, let's label her name here. And she was represented by that graph that we had. Let me pull that back up. Okay, this graph represented Brina's velocity. Now here's what I mean by total distance traveled. Okay, she traveled to the right, then she traveled to the left, then she traveled some more. Okay, so if I add all of these together, I would have to take this guy and take its absolute value to get her total distance. Okay, if I took this as a positive and this as a negative, they would cancel each other out, and I wouldn't be walking as far as perhaps you might think. All right, so I need to go and get the areas of each of these. So I'm going to go 1/2 base times height. I've got 4 times 1/2 is 2 times 0.2 is going to be 0.4. Okay, I've got, let's see, 3 times 1/2, so that's 3/2. Times 0.2 is 2/10. That's going to get me negative 0.3. And then I've got a monster trapezoid, which I'm going to break up into some triangles and a square. 3 by 3 is 9. What does this get me? 0.45, I believe. And 0.3. Hopefully my math is correct. All right, now I want you to think about this, and we're going to label this 2 different ways here. If you just add these, you get what is called displacement. Okay, displacement or net change. Okay, if I add them the way they are, if I take 0.4 minus 0.3 plus 0.45 plus 9 plus 0.3, that gets me, again, the word displacement or net change. However, if I want the total distance traveled, okay, I need to take the absolute value of all my velocities. So I would say it's actually 0.4 plus 0.3 plus 0.45 plus 9 plus 0.3. There is a very big difference. Again, if I just add the numbers the way they are, that's called displacement or net change. That's canceling out some of those areas. However, total distance is taking this -3 and now making it positive to show that I actually was still riding my bike during this section. Okay, so if I add those together, I would say Brenna's total distance traveled is 2.35 miles. Okay, so the question said, who traveled further? Brina or Alvin, I think his name was. So now let's go get Alvin's. All right. I'm going to integrate from 0 to 16 of v of the absolute value of v of t dt. Okay, so again, scroll back up here. Alvin traveled at this velocity. I need its absolute value because I'm finding its total distance traveled from 0 to 16, it says. So 0 to 16, taking the absolute value of my 1/16th, I apologize, 1/20th radical t dt. Okay, now, because it's absolute value, this is one you have to sketch. Okay, I know the square root of t looks like, and I'm going to multiply all that by 20. Again, if you don't know, to plug in 0, square root of 0 is 0 times a 20th. The square root of 4 is 2 times a 20th is 1/10. Obviously, it's just going to grow super small like that from 0 to 16. Now, because this is all above the x-axis already, I don't need to worry about the absolute value, actually. That will just disappear. All right, so let's go ahead and integrate. This is t to the 1/2, so t to the 3/2 times 2/3 times my 1/20 from 0 to 16. So I'm going to multiply these numbers out front. So that's 1/30 t to the 3/2 from 0 to 16. Let's see, so I've got 1/30, 16 to the 3/2 minus 0. Square root of 16 is 4. 4 cubed is 64. I get 64/30, which is approximately 2.133. So who traveled further? 2.35 compared to 2.133. I would say Brina traveled further. All right, last question for the night, actually. This question says, who lives farther from Sarah's house? Okay, Brina or Alvin? All right, so let's go ahead and take a look at Brina's graph again. Okay, so remember, this is her traveling to the right, to the left, and to the right. She left home. Okay, she's riding her bike to the right till she gets to 4. She forgets that calculus homework, turns around, comes back to the left, drops and picks it up from wherever she dropped it, turns around and comes back to the right until she gets to Sarah's house. Okay, so would you agree that this is just kind of overlapping time here? That's not really her distance from Sarah's house. Okay, so if I just want to find how far she actually lived from Sarah's house, I would just take those pieces I have and add them up. Okay, I want them to cancel this time. So I'm going to take my 0.4 minus my 0.3 plus my 0.45 plus my 0.9 plus my 0.3 to say that she lives a total of 1.75 miles from Sarah's house. Now, Alvin, on the other hand, okay, he didn't drop anything. He just strictly went from his house to Sarah's house. So nothing's going to change in that case. I believe he had a total from our previous problem there of 2.133 miles. So I think it's safe to say that poor Brina lives closer to Sarah. She only lives 1.75 miles away. However, she had to ride her bike a little further because she dropped her homework and had to go back and pick it up. And Alvin clearly lives farther. So in conclusion here, if we can sum up our one mega topic from tonight, is the words total distance traveled. Okay, and I need you to understand by tomorrow that total distance traveled is the absolute value of velocity. Okay, total distance traveled is the absolute value of velocity. Well, like I said, that does it for us tonight, and I will see you tomorrow.